Hey guys, so last week we spoke about time and how Einstein says that things get all wonky with it.
But this video is all about space.
So what exactly is space?
Nobody really knows.
It's just been really difficult to go through life knowing what space is. People say weird things about space and I find it very offensive. And you can't research anything about science anymore without it all being about special relativity and general relativity and all that quantum crap. I just wish that physics could go back to the way it was when Isaac Newton came up with his theories. Why can't physics just make sense,
So to start with, we have nothing. Just absolute nothingness. Now let's add a graph with an x-coordinate and a y-coordinate and a z-coordinate. The 3 dimensions of space. And then we add some universe stuff. You are here. And then we add some time into the equation and then you get movement. So here's you busy driving in your car. And then this is you on the surface of the Earth while it's spinning around its axis. And then that Earth is spinning around the Sun. And then that Sun is spinning around the black hole in the middle of our galaxy. And then that galaxy is flying outwards into nothingness. And all of those movements happening together at the same time gives you this curve over here, which is you moving through space. Okay, now we take away all the universe stuff again. And the only thing we leave behind is that movement which you did through space. The movement you did through nothingness. So space isn't really this thing per se. It's more like that vast emptiness which stuff occupies. And then when it comes to space, we refer to your geographic location in that vast emptiness. So if you look at your x, y, and z coordinates again, we're looking at your position on those coordinates. Your position in space. So if we took all of that universe stuff away and pinpointed one location on that graph in space, and now we put all the universe stuff back and let the universe stuff move again. Do you see how the position of all the universe stuff keeps changing? But that spot that we pinpointed is absolute. It doesn't move. In that vast, unchanging, 3-dimensional emptiness, which is space. So what is scientist and Mr. Einstein's definition of space? Well, the understanding of space is kind of like this checkers bag. In other words, it's trash. So it's like this 3-dimensional thing that you can bend and move and stretch. But now let's have another look at my definition of space and see what happens with the checkers bag. Okay, so here's the checkers bag to represent the space. Now like before, and let's plot the x, y, and z coordinates on here. And then we'll draw a border around this checkers bag to show where it's occupying space. And now we're going to move and bend and stretch and warp this checkers bag. Now if you ask me, that red border which isn't changing is space. And the checkers bag which is moving and bending and stretching is the universe stuff which is occupying that space, and not space itself. Because like I said, space isn't a thing, it's not stuff, it isn't a something. Here's a video that explains general relativity for us. So let's go through it step by step.
General relativity is the idea that gravity happens because space is curved. Like how when you walk along the surface of a ball, you end up curving downwards. Actually, general relativity is the idea that space and time aren't separate. Time is a physical dimension, and together they form a single geometry called space-time. And gravity is caused by curvature in space-time.
Okay, so this line over here is space-time, and a small object being on that space-time will curve it just that ever so slightly. Now if we place a bigger object next to that small object, then it will curve space-time even more. And then what they would say is that this causes that object to roll inwards over here. Now intuitively that makes sense to us, because if we had to think of a ball on the top of a hill, then obviously that ball would roll downwards. But remember, that's only in our normal world over here in a 3-dimensional space. But we're not talking about that over here. And also, that curvature over there isn't actually downwards. It's more inwards, as you can see in this picture over here. So intuitively, when we see this explanation, we already think, oh, that must be correct, because we're thinking of that situation and not the situation that scientists are actually talking about when they show you this explanation. And that also means that there isn't this force pulling downwards which is moving the object inwards. Well, Einstein's reasoning is that it's because of inertia. Now, inertia is Newton's first law, which says an object at rest will stay at rest unless acted on by an outside force. And an object in motion will stay in motion unless acted on by an outside force. So he says this object is already in motion through space-time, and it's just following this curve that it would naturally follow towards the other object. But that explanation doesn't make any sense. Think about what he's actually saying. He's saying that it is your movement through space-time, your movement through space and time. Because what exactly is meant by motion through space-time? So we have our 3 dimensions over here, and obviously that object is at rest in those 3 dimensions. So there's no movement over here. And now each of those 3D spaces are like a slide over here, and that is moving through time. But that movement through time is just a movement from past to future. Essentially, that means there is absolutely no movement taking place here. So again, how does all of this explain this movement inwards? And the answer is it doesn't. Okay, and then we have the other problem with the explanation. If you look at this demonstration of how the curvature of space-time works, you'll see that all of the planets eventually end up in the middle where the sun is. So why is it that the sun's gravity doesn't pull all of the planets into the sun like we see in that demonstration? So according to the Newtonian understanding of the universe, we have the sun over here, and then we have a planet orbiting that sun. And the reason we have that motion is because we have the sun's gravity pulling the planet inward. But as the sun is pulling the planet inwards, it's also spinning the planet around. And that circular motion causes a centrifugal force, which makes the planet want to fly away from the sun. And it's this balance between the inward force of the gravity and the outward force of the centrifugal force which keeps the planet in that balance in the orbit around the sun. Now with Einstein's explanation of how gravity works, you don't have that balance, because he says that the reason why you have gravity in the first place is because of the planet's inertia. So if it's the planet's inertia which causes it to move towards the sun, then there is no inertia to move it away from the sun. So you see, with Einstein's explanation, they are using the planet's inertia to explain why the planet is moving towards the sun. But then in the same breath, they are also saying that the reason why the planet doesn't fly into the sun is because of the planet's inertia. So which one is it? Okay, and now let's go back to what they were saying about gravity bending space and time. So if we take a black hole as an example, they are saying that space and time gets infinitely bent in the black hole. Now think about what you are actually saying when you say that. For one, what you are actually saying is that time infinitely slows down inside a black hole, which means it practically stops inside a black hole. Now if time stops, there is no change, there is no movement. Which means since the creation of that black hole, the black hole hasn't gone under any changes or any movement because time completely stopped for that black hole. So for billions of years, nothing ever happened to that black hole, and nothing can ever happen to that black hole because time stopped for the black hole. And to say that space is infinitely bent in the black hole, actually picture what that means. You want to say that all of that space is inside a black hole which occupies a certain amount of space which we can actually measure. Besides the fact that black holes actually aren't even black holes. The name is misleading. A black hole is an object like the sun which is very dense. And it's because of that density and that immense amount of gravity that light can't escape from it. A black hole is a thing in space, not a hole. So again, if you think the logic is flawed in my videos, or if you think I made a mistake anyway, I'd like to invite you to come onto my channel and to have a discussion with me about the topic. That's all we have space for this week.
Peace out.
So what the hell is that noise?
Look at my pretty layout. Route 66. There's my Nikon camera. My old age Nikon camera. French. It's all French. Check it out. That's all French right there. French books. How sick is this photograph? I found it in a house that we moved into. Minos. That's the movie Escape Room 2. Check it out. I'm in it. Minos. Opium black. The stuff smells amazing. Camera's battery and charger. My fancy little camera stand.
Joe.